So let's take a look at this chain and sprocket system, because this problem in particular is one of the problems where you can use these equations that we've already learned, these equations here, to find a missing variable, which is what we're looking for is how much torque do we need to put in order to receive 120 foot-pounds out. So these equations are the same equations as we had for the gear ratio. Even in the previous slide, we have all of the same equations except for the number of teeth for a belt and pulley system, because belt and pulley systems do not have teeth. But we have our diameter equation, we have our angular velocity equation, and our torque equation for a belt and pulley system. With a chain and sprocket, we get that teeth equation because a sprocket has teeth. So what we're going to do is we're trying to solve for our torque in. How much torque do we need to apply to this red sprocket in order to get a torque out equal to 120 foot-pounds? That's our goal for this problem. So we can use any of these ratios that we would like. We could use the number of teeth, the diameter, or the angular velocity ratio to help us find the torque in. So I'm just going to use the angular velocity ratio. So the angular velocity in divided by the angular velocity out is equal to our torque out divided by our torque in. So we plug in what we know. So our angular velocity in is right here. This is our in gear or our driver sprocket, and it is 90 RPMs. So 90. And then our angular velocity out is 45. So we get 90 divided by 45 equals T out, we know is 120. That's what we want to get out of this. It's also listed over here. And we want to find out how much we need to put in order to get that much out. So we solve this equation. We can type in 90 divided by 45 into our calculators and we get 2. So I'm going to solve the rest of the problem over here. So we have 2 equals 120 times torque in. Solve for this. You can switch that to the other side and then divide by 2. So you have torque in is equal to 120 divided by 2, which equals 60. And it's foot-pounds. So this is an example of how you can use these ratio equations to help you solve for something like how much torque I would need to put in the system if I wanted to get so much out. Or what diameter of sprocket would I need to pick if I want to use a 3-inch diameter sprocket as my output sprocket. So this is just a helpful way where you can use these equations to help you find unknowns.